on page 70 in PILA. So what you had for this lab report, on 68 you had your materials needed, and I likened that, I compared it to a recipe with your ingredients list. Then 69, yesterday, I read through those. That was your procedures, which would be maybe the paragraph or two or more underneath the recipe telling you what you're supposed to do step by step and in the right order. So the rest of this lab report that we're reading, one day you'll have to come up with your own for a science class. You have an explanation. So you don't get that with a recipe. Now, if you Google a recipe anymore, which I do, yeah, it's surprising how few cookbooks I used to buy a lot, don't buy a lot anymore. So Googling recipes for anything gives you the materials needed, the list of ingredients, gives you the procedure, what to do with them. If you do look at the end, though, of the web page, sometimes it does give you an explanation with some commentary as well. So that's what we're going to be looking at now, and we're going to have James start to read that on 70. Yes, sir.
Why do we still have the Frankenstein?
I'll be picking those up once we can get further along. We're a slight bit behind because of Friday. Yes, ma'am.
I have a question.
And time vampires.
Didn't James start yesterday?
No, James has not started in days. He's not had his progress book, so we're starting here. All right. Explanation, James, page 70. That's that paragraph 4.
Explanation. It's all about transfer of energy. Some of the energy of the larger ball is transferred to the smaller one. Notice that you most likely concentrated your attention on the high-flying smaller ball. Try it again to see what the larger ball does. It barely bounces at all. This is because its energy passes directly to the smaller ball. The smaller ball is having less mass and it goes rocketing into the air. Oh, and don't forget gravity. The smaller the ball is flying through the air, gravity is slowing it down, changing the kinetic energy at work into potential energy, stored energy.
So this is that experiment that they were asking us to try where you actually put the small ball, like a tennis ball, on top of, say, a large ball, like a basketball, and you try to drop them both at the same time. They're saying that basketball is kind of going to land with a thud, and the tennis ball is going to take off. Yeah? And part of that is going to be the gravity that you're talking about there. All right, let's take a look at paragraph 5, please, Skylar, with explore it further.
Select from your
Variety
of other bouncy balls and see what happens. If an even lighter ball is on top, what then? What if a bigger ball sits on top of the smaller ball? What if you stack 3 balls, largest and the bottom, then the middle sized ball topped with a small ball? Which ball will travel the farthest?
Yeah, I mean, part of science, when you actually start to think of how science is absolutely everywhere and almost everything we do, part of it is to just be curious. Okay, I did that experiment. All right, well, what happens if I go get a whole bunch of ping pong balls? Ping pong ball versus tennis balls. Well, who's going to win?
Ping pong.
You know? So it's just about being curious. Yeah, you're going to have to get something else because that's just not working. So you need something else to write with. All right. Now let's take a look at, thank you so much, Skylar. Lathan, paragraph 6, please.
As you try the variations you can think of, consider how Newton's laws and the ideas you have learned about energy apply to the experiment.
Okay, let's take a look up there at the citing evidence on part A. It says, in this experiment, why does the larger ball barely bounce, but the smaller ball flies? Now it says to circle the sentence that explains. I need to tell you, go to paragraph 4 for that. Go to paragraph 4, look toward the middle of it. You are looking for the sentence that explains the larger ball barely bouncing, but the smaller ball flies. They want you to circle that one. Paragraph 4, toward the middle. Let's let everyone have a chance to look. Did you see it? Which one did you find?
I found this is because the energy passes directly to the smaller ball. The smaller ball, having less mass, goes rocketing into the air.
Yeah, and I concentrated primarily on that first sentence, but both are great because that second one gives the complete explanation. Yeah, the complete explanation there. So you've got, this is because its energy passes directly to the smaller ball. And then James went on to say the smaller ball having less mass goes rocketing into the air, but particularly that first sentence. Yes, ma'am?
I put the sum of the energy the larger ball is transferred to the smaller ball.
Yeah, but we do want to know, the other sentences explain why better. All right, part B. We're going to stick with paragraph 4 for this one. Underline the sentence that tells what kind of relationship gravity has with energy. Still paragraph 4, and I don't believe that James started talking about gravity till toward the end. Lily Grace, what'd you find?
I put gravity is slowing down, changing kinetic energy into potential energy.
Yeah. Gravity is slowing it down. Really, it's that last full sentence. Did y'all get that one? Where it was talking about gravity? It's pretty easy, right?
Yeah, that sentence was pretty long.
That was a really long sentence. Well, that sentence, if you take a look at it, as the smaller ball is flying through the air, comma. You see that? That's known as an adverb clause. And that comma is there because the adverb clause that begins with the subordinating conjunction, they're all different types of conjunctions, as it begins the sentence. Then you get into the real part of your sentence with gravity is slowing it down, then changing kinetic energy into potential energy. I gotta tell you, that type of sentence right there would be really fun to diagram. Really fun. There's a lot of grammar going on into that sentence. Yeah, I love diagramming. I missed my grammar class, people. All right, let's go to page 71. And actually, Lily Grace, it's your turn. Could you read paragraph 7? Lathan read, right?
What about me?
Chloe?
Hi. You
Lily,
didn't see her?
Lily Grace, I'm so sorry. Okay, for real? I did not. Hold on. Yes, sir? Huh? Sure, just go. Chloe, would you read paragraph 7, then we'll go to Lily Grace, because that is my bad.
When you have tried all the various balls you have to use, try other combinations.
Comparisons, yeah.
Comparisons. If you drop a basketball and a ping pong ball from the same height, which bounces longest? Why do you think that is?
And I think we called it before. I mean, my money's on the ping pong ball. Most stuff. Okay.
I mean, ping pong balls don't bounce. Yes, they do.
Oh, really? I mean, when you hit it and then the other person doesn't, it can keep on going. It's like one of those. Did you ever see Men in Black?
No.
Oh, man, you gotta watch that.
I've
Okay.
seen
Yes.
There will be a scene in Men in Black that will remind you of that. All right, Lily Grace, now back to you. Paragraph 8. End it for us before we do our comp check.
Keep an experiment log that records the results of each experiment. Include your hypothesis and a description of your results. Explain whether the experiment supported your hypothesis, and with an explanation of why you got the results you did.
Yeah. So one of the things that on Monday, during the teachers' meeting, a room I'm going to set up is a conference about labs in science. And you can really, just with these experiments here, kind of make it fun. Yeah? And if we do get to do a science fair where y'all could do some fun experiments just like this one or the next one with the penny drop, I am there to help you write that lab report because it's going to be very similar to what we just read, the 3 main parts of it. Materials needed, how to do it, and then explaining. why that happened. So I'm really hoping we can kind of move forward. Let's see how Monday goes. I'm giving the teachers a class.
That's creepy and that's
Why are you
creepy.
teaching the teachers? You're not Miss Liz.
Well, every once in a while, it's good to keep on learning, maybe.
You should be our science
But we
teacher.
learn every day.
I'm just saying, just because you're old doesn't mean you stop learning.
Yeah,
But we're
Daniel.
still learning.
And I like science fairs.
You're
I think
old.
they're fun. Yeah, if you remember the Veterans Day Assembly today, Miss Liz had me 10 years older. She thought that she taught me in the 1970s. I
think
had
you're
to
like
say
22.
something. Sorry.
I think you're like 22.
Oh my gosh, whatever.
Wait, did she teach
Aren't you like 50?
Yeah, 47, Lathan. Used to be my favorite. Look at your comp check. Let's do 1 and 2. We'll do 3 together. 71, be careful always with multiple choice. Read through all of them and pick out the best one. So you're going to be looking for which of the following concepts related to Newton's third law of motion is the key concept behind this experiment with, say, that basketball and that tennis ball. I will go ahead and tell you right now, that one's hard. Number 2, what causes kinetic energy to change to potential energy once the small ball is in the air? And then I'll remind you again to go back to that paragraph that James read for us. So take a minute and do 1 and 2. I know that 1 is tough, and we'll do 3 together. Yes, ma'am.
Can I do number 1?
Oh no, we're gonna give everyone time. Number 1 is difficult, sir.
Can I use the restroom?
Yes. Let's give them a few minutes on this. That's 71 on 1 and 2. I'm just going to say the question in number 3 is really helpful for number 1. I often tell this to my middle school. Sometimes you can use a test to take your test.
Yep.
If you are having a very hard time with number 1, just read through number 3. Yes, sir, Daniel?
Can I use the restroom after this?
Absolutely.
We have another open book test.
Oh, we are, but we're going to read about octopi and squid first.
Whoa.
Arif?
Are any of my tests on this unit now?
Arif?
Open?
Arif?
Never mind.
No, I'm sorry. Just can't, you raised your hand like a patient person. What you need, boo?
I just wanted to do number 1. I thought we were ready.
Oh, hold up. Yes, ma'am.
One time I was on a test and there was the paper and I couldn't do number 1, so I skipped and the answer was wrong.
Yeah, we often do that, and the reason we do it, particularly at your age and a little older, is we want to make sure it's not really about what you're learning and what's on that test. We just want to make sure that you're not learning the bad mistake of being careless. Yeah? So if you're always paying attention, and if you're in that moment and always doing something that's super important very carefully, there will sometimes be gifts on a page. Yeah? Using your test to take your test. I can't tell you how many times I'll get back a 7th or 8th grade big giant test and I'll ask them like randomly, why did you miss number 10? Look at number 18 and they'll like, oh, really? You know, they were just flying through it and they were just trying to get to the end. It's not a race. There's never a time when a teacher looks at a person who turns in their test first and says, wow, that was awesome. No, if you turn in a test first, you scare me. You know what I'm saying? I'm middle and last on turning in tests. Yes, sir?
One time I was having a test. Let's just say it was addition, because I don't remember. And it was like 5 plus 5 on number 9. And then on number 10 was like, if 5 plus 5 equals 10,
Yeah.
then what is 10 divided by 2?
You always have to check and see if people are paying attention on a test. You know? All right, Arif, what was 1?
I could see it.
Transfer of energy. Did not number 3 help you? I mean 4 real. Because 3 that we'll talk about says with a partner discuss how the experiments and information in the text help you to gain a better understanding of the transfer of energy. Okay? Number 2, what causes that kinetic energy to change to that potential energy once the small ball is in the air, okay?
Gravity?
That would be gravity, because I was letting you know you had to go back to the paragraph that James read, and it was the last sentence that we actually underlined. Yeah, that gravity is a force that plays a major role there. Now, when you take a look at number 3 to just discuss how those experiments and the information help us to really understand what transfer of energy means, really, it's about having that larger ball and having that smaller ball soaring into the air, and then just realizing how the energy from one is transferring to the other. If they're telling us to expect, if we put the tennis ball on top of the basketball, if they're telling us to expect that basketball to just kind of fall with a thud and then the tennis ball keeps on bouncing, what they're saying is the bigger ball, the one with more mass, gave that tennis ball more energy. It transferred it. Science is really rather magical. You know, so I hope that you are excited when I teach the teachers how to do a science fair.
Yay!
And Daniel, I can because I'm the director of middle school.
Oh, okay. Then
You're the second.
Well, the thing is, as long as you don't look at it as a curse, and as long as you look at a science experiment about being just really curious, you know? Like if you were to do this one, I think this one would be really interesting, and I could actually see you getting a little bit virtual with this one. What if you had maybe your iPad or phone going and you actually had it on a loop where you filmed it? Yeah.
someone did that. I
What
saw
if
that on
you,
YouTube.
along with the trifold and all that other stuff and the great stuff you cut out and things you wrote on there. I know that your hand's up. So, what if you tried this and went bigger and badder, bolder, and you tried every type of ball that you get your hands on, you know, and then you crowned one of them the supreme winner of transferring energy, or you know what I mean? So as long as you're curious, this whole thing could be pretty fun. Yes, ma'am. Absolutely. Maya, you read, didn't you?
No.
No? We're to you. Maya, we're going to 72. The disappearing penny trick. It could be a science experiment. Let's go.
Disappearing penny. For this experiment, you will demonstrate the basics for inertia. The tendency of an object to keep doing whatever it is doing until a force acts on it. This is Newton's first law of motion, and there is nothing that escapes it. As you sit at your desk reading this experiment, you too are the state of inertia.
We definitely are in a state of inertia. An object's at rest. And will stay at rest until something acts upon it with an outside force, which tends to be your mama.
Yep.
I use inertia a lot when my kids, once again, I'll say it because we did when we were on the primary story about Newton's 3 laws. I mean, if my kids are getting too much screen time, I will say, why are you being so inert? Why do we have so much inertia going on in here? And then it really takes a mama to be like, give me your iPad. Go do something. Get up.
Lose some weight.
You know, growing up, I think with your parents' generation, my generation, I know that a lot of people might complain about screen time with y'all when it comes to video games, iPads, whatever you got in front of you, computers. But your grandparents had the same problem with your parents. Yeah? I know my mom was constantly telling me to turn the TV off, go do something, get outside.
never did that.
It was TV. It was TV during the 70s, 80s, early 90s. Yeah, that was our screen time.
And then
And I would recall a mom, typically, sometimes a dad, grandparents being like, why do they watch TV so much? These kids these days.
My grandma does.
I couldn't imagine, you know, what my grandparents would think now with my kids walking around with a screen.
like with phones.
I would be the one getting the lecture. You know how grandparents do, because they love their grandbabies.
My grandma
So we get
treats
the
me like a
lecture.
0. Literally.
All right, materials needed. I will read through this and we'll go to John. All right, so here's our list of ingredients. We need a clear plastic cup. Doable. We need a penny. Can I just say not doable for me anymore with this whole I have to spend exact change in a store anymore? I am out of pennies. Yeah, I am out of pennies.
Same. I'm $1.20.
Now, they suggest a playing card. I have heard a sheet of paper will be fine, but you might want to watch out for the sheet of paper. It tends to be a little flimsy. I would definitely go for the playing card. All right, John, would you read the first 3 bullet points there for us?
Yes, ma'am. As you conduct this experiment, make sure an adult is nearby to supervise. Place the playing card on top of the cup's opening. Set the penny on top of the playing card so that it is positioned over the middle of the cup.
Okay, maybe the first procedure is a little weird.
Why do you need
I don't
pencils?
think that you're of the age right now, like a 2-year-old, where you're going to put the penny in your mouth.
Parental supervision.
Yeah, I'm not quite sure we
Nope.
need that one. All right, so we know what we're doing. We're going to place the playing card on top of the cup's opening. Then we're going to set the penny on top of the playing card. Yes, sir.
Would it have to be like a clear solo cup or like,
No, that doesn't matter. It doesn't matter what type of cup.
could it be a glass cup?
It could, yes, it could. Yes, ma'am. All right, Charlie, would you read the next 2 bullet points, please? They're a little longer.
Hold the cup firmly. Then, with the penny still sitting on it, whip the card off the top of the cup. Sure, you keep the card flat. You can also just pull the card towards you with a sharp tug. Remember to perform the procedure at least 3 times. You will need to test your results several times in order to draw a valid conclusion.
Yeah, you know, I mean, I don't know. You never just want to try something once, you know? Try it a few times. Now, what if you actually do make this into a science fair project? Then you're going to want to have a piece of paper and do 1, 2, 3, however many times you want to try it, and write down the results. All right, here's the first time I tried it. Here's what happened. The second time I tried it, here's what happened. The third time I tried it, here's what happened. I am a very uncoordinated person, so I bet you anything, my first time is going to be like, I didn't pull the card out right. Penny went flying.
That's me.
And then the second time I probably started getting aggravated. I pulled the card out too quickly, and the cup fell over. You know, you have to, right, you have to write down all the little mistakes that might happen. That's part of the experiment. All right, Rahel, the last bullet point and the question at the end, please, on 72.
Write down your observations of what happened. How many times did the penny drop into the cup? Did the way you flipped the cards change what happened to the penny? So, why did the penny fall into the cup?
You're only really pulling the card. The card is the one receiving energy. That penny's just like hanging out.
Yeah, it's like that trick where you put a bunch of glass cups on a table and you pull the
And you
table
pull the
out.
sheet out, the tablecloth out very quickly. It is the, yes, it is, that is the same thing. I've seen it done. Craziest thing. Taylor, last part of our science lab report here on 73. Paragraph 10, please. I do want to read that before we look at citing evidence.
Okay. Explanation. Because the penny is
Has inertia.
inertia, its tendency is to keep doing what it is doing, which is nothing. When one quickly flicks, you see the power of
Inertia.
inertia, which holds the coin in place. If you like, you can even try the same experiment using your finger instead of the cup. It's tricky, but with practice, you can do it.
So putting a penny on your finger and just trying to pull.
How in the
Yeah.
world?
It's, yeah.
Can you like
It's just
pop
gonna
it,
all
like,
fall.
push it up and-
I think the coupling would be better if this might be the science lab that you want to try. Hey, go back to 72 and let's take a look at citing evidence. It says underline the step. Now this would be in the list of procedures, the bullet points, okay? Underline the step in the procedure that will show a relationship between the action performed on the card and the penny. Oh, gosh. You want to read through all of it about the setup, where you put everything. Get to the action part of the procedure. Get to the action of it. Right after the setup, what is the action? I need to let her know that wasn't working today.
I want to just circle the whole entire big paragraph right now.
For that one, really on A? No, I'm hoping that you went down to the 4th bullet point.
I did.
And you got then, after of course holding the cup firmly, because you are talking about the relationship only between the card and the penny, then with the penny still sitting on it, whip the card off the top of the cup.
Whip. I got that.
That's the action part. That's the action part.
At first, I really thought I was going to circle the whole entire paragraph or something.
No, that's just the action. That's what we're supposed to do. That's why we just did the whole setup. The rest of it is what happened to the penny. Yeah? Or, remember, you have to record your mistakes. Listen, mistakes in science labs are very important. Plastic was a mistake.
Yes, it was.
Plastic was a mistake.
You're right.
The scientists were trying to do something else, and boom, we have plastic.
Why do we have what the?
Exactly. Okay? So you have to record your mistakes because sometimes mistakes are just little gifts of success, and you think it's a mistake because it wasn't what you were expecting. That's not what you wanted. That wasn't what you were planning on. But it could be a happy thing. Yeah? So that's why they say do record any of your mistakes. All right, for part B, this one says to circle the sentence in the procedure, still on the bullet points. We're definitely going after what we just worked, which was the 4th bullet point. Got to go below that. So circle the sentence in the procedure that explains why you might need to perform the experiment several times.
That's easy.
Yeah.
Yeah. Really easy. Found it.
Particularly for a very uncoordinated person like I am. Now with this one, did you get
The last.
you will need to test your results several times in order to draw that valid conclusion? Alright?
Yes, I got that.
Awesome. Yeah. You need to show at least three tries at least. Okay? So if we do have a science fair and you go to draw a conclusion on something, just make sure you tried it at least 3 times. Yeah? At least 3 times. Alright, now let's go to this comp check. 1 and 2 I think will be a little bit easier than the last 1 and 2, but those seem to go pretty well. Number 1 says what force described in the bounce versus bounce experiment can you infer, best guess, acted on the penny to make it fall into the cup? Well, just, oh no, let's give them a minute. Just kind of think about that one. What would make a penny fall, literally? Number 2, what is the relationship between that bounce versus bounce experiment and the disappearing penny experiment?
That was easy.
Wasn't that one easier?
Way easy. That was easy. Just boom, boom, done.
Right.
Can I do number 1?
Yes, Clay. What force described in that bounce versus bounce made the penny fall?
Gravity.
Amen, sister. Gravity. Get it off your head and put it on correctly. Number 2, what is the relationship between bounce versus bounce and the disappearing penny? Well, what have we been learning about, John?
They both demonstrate Newton's laws of motion.
Yeah. That's what we've been learning about. Yeah. Absolutely. So, I mean, if I just said, okay, I need for you to do a lab on inertia. Yeah. My 7th and 8th grade would freak out.
I would too.
But no. You're gonna do the disappearing penny trick. Yeah? Okay, you're doing inertia. You're gonna do transfer of energy from Newton. My 7th and 8th grade would freak out, but y'all know, we're gonna do the ball experiment. Yeah? Okay, then going back as far as his first law from Newton, it could be a super cool video experience for a science lab where you could talk about bumper cars. Yeah? It's just ways of making science kind of fun. And then, of course, if I looked at another person and said, and you will explain how to denature a protein.
Baking.
That was cooking the bacon and the eggs.
Or baking.
Yeah, absolutely. Absolutely. So you don't have to really be scared of it. You just have to be super curious. And you can really make them fun. Super fun. Yes, sir. I think so. Yeah, absolutely. I don't think, because we've got, that's Chance though. I'm not used to the new seating arrangement. All right, cool. Now, here's what we've got going on. Did you ever go?
No, I think after.
No, you went.
I thought you were supposed to go after. Okay, someone. We need to get through octopi. I'm old school. That is originally how you make it plural. Octopi and squids. This one's going to be fascinating, or at least I found it so fascinating. Getting through this, and then there's no real citing evidence on it. It's just a really cool, interesting story. A little bit of comprehension checks. Then, to answer Taylor's question, but as a reminder, we'll do the open book quizzes, yeah? We've really, I think, when you take a look at the bumper cars and the bounce versus bounce and the penny drop experiments, like those are super interesting. So I only have maybe 8 questions for that. Get through squids and octopi. And it's okay to call them octopuses. It's just, well, it's the secondary. It's kind of like, okay, we're tired of like correcting people who are constantly getting it wrong, so we'll let it be right. It should be octopi. It's super interesting. This one is so interesting, and how you can apply what they can do, and some of the things are going to freak you out that they can do. Like still in my head, Cammie and I are like, what? Because we were reading this the other day, and we saw a video of it happening, and we're still freaked out a little bit. That's tomorrow, Cammie. Yeah. Sound good?
Yeah.
All right, cool. Well, yeah, as usual, no homework.
Bye.